I'm Matt Treinish. I work at HP on all upstream OpenStack, and I'm also the PTL of the QA program in the community. And I'm going to be talking about subunit2sql, which is a little project I started to track all of the test results from our Tempest runs in the gate. So I should talk a little bit about the size of our gate to answer to show what the question I was trying to solve was. So basically, every proposed patch to OpenStack launches 4 to 25 DevStack environments, which we run about 1,500 Tempest tests against once that cloud is deployed. As part of that, we launch 130 second-level guests in a public cloud as part of that test suite. So we're launching 130 guests on that DevStack cloud we set up. Looking at that in aggregate for the month of December, we launched 12,000 Tempest jobs approximately. Okay, well, let's move on. So what was missing? We ran all of those tests, but we didn't have a way of looking at everything at the whole. We could look at individual test results, and we had a log stash where we could look at 10 days worth of history, but we couldn't look at the overall release, for example, all the test results from a release. We also couldn't check like success and failure rates of a test over time. Like if we had a race condition, we wouldn't be able to identify when we decreased the failure rate. And we also weren't able to measure runtimes or do performance testing over time. The gate is very noisy because it's all second-level virtualization in a public cloud. And we couldn't really do performance analysis of all of this testing we're running. So subunit2sql was what I came up with for the answer. It's a Python library and a set of utilities on top of that library to set up a SQL schema to track all of the test data. Luckily, this data we track is very whatever. There are 4 utilities that are part of it. Subunit2sql, which takes in a subunit stream, which is the machine parsable output we have from all of our test runs, and stores that in the database. SQL to subunit does the reverse, where it pulls a subunit stream out of the database. Then there's a tool to manage it, and then a graphing tool, which will talk to the database and pull and generate fancy graphs from the data in the database. So this was an example I did for performance regression testing. So this is just runtime, graphed over time for about 2 months. And what I noticed was there's all of that jumping up and down, which means that in certain cases we were having a really bad performance. When it's at the top, where it's about average, it's a lot slower, but sometimes it's really quick. And you can see also how noisy the data is in the middle. You see all of that rippling just in the normal case. And so I did some metadata filtering when the slide changes. It'll show when I filtered it, but it turns out that on the stable branches, here we go, so the fast is stable Icehouse, and stable Juno and master, because this was Kilo at the time, are those top 2. So it basically means from Icehouse to Juno, we introduced a performance regression that was adding over 100 seconds of time to this one test, which just sets a VM in a rescue state and then tries to detach a volume. It was the volume attached that was the volume detached that's taking all of the time. And the top line is a unknown race condition that's causing an additional performance regression. But you can clearly see that we were able to identify a performance regression that we weren't able to without having the database and the ability to track things over a long time. And it turns out in Kilo we fixed it, and you can see where the average drops down there. The issue with the spiking is because stable Juno is still broken. We haven't backported the fix. But you can see quite clearly where in March that we fixed the performance regression in Cinder that was causing the time. So you can see we saved about 100 seconds on average from all of the gate runs. And this is the new format for the previous graph. I made it a little prettier. Yeah, so performance analysis is something that we can do now using this database in production. Well, we can stare at the graph a little bit more while we wait for the slide to change. Oh, there we go. The other thing we can do is track test failure rates. Turns out we don't actually fail Tempest that often in the gate. What we fail is the infrastructure and the setup process. So this is just one test that failed a little bit more than others. And you can see over time when we have spikes of failures related to something in the gate not working or a bad patch. So one of the graph utilities can generate this graph, and you can also show status things. And it also prints out the percentages, and you can see how successful just this one test is, and this had one of the higher failure rates from the database. I wanted this personally as the Tempest maintainer to track things and make policy decisions about removing tests. So where can you get more information? This means nothing in a presentation like this because those are hyperlinks. But there are links to the repository, the documentation, and then there's also all of this is in a public MySQL server that anyone can log into. And the credentials for logging into it and the connection information is there if people wanted to play with the database. And I'm also on IRC all the time if people are interested in this, whether they want to use it themselves or play around with the public data we have available. So I guess that's it. Thanks, everyone.